International Day of Light celebration, IEEE Photonics Society chapter, in association with International School of Photonics, invited entries for a Photonics Innovation Challenge 2022 to present an idea that uses optics and photonics to create innovative products, applications, and technologies. Among the many entries received, 4 contestants have been selected to present their ideas. At this juncture, I invite Dr. Kailas Natsar, Vice Chair, Photonics Society, Kerala Chapter, to deliver the welcome speech.
Very good afternoon to all. Today, we are going to witness a very special event. Even though very small, it's going to be a great start as far as the innovation and entrepreneurship initiatives of ISP is concerned. If you consider the technology and the light-based technologies in particular, it is actually growing very exponentially, and at the same time, the adaptation time of the technologies are actually coming down drastically. So in order to be relevant in this field, every organization, every institution, and as individuals, we have to start thinking about innovation. And this is the first time we are talking about such innovation and entrepreneurship formally, apart from including those things in our syllabi. So today, we have this Photonics Innovation Challenge, which is actually meant for the graduate and postgraduate students all over Kerala. And it was not well circulated or well informed in advance. It was actually as part of the International Day of Light celebrations 2 months ago. We coined this idea, and it was extended. The deadline was extended twice afterwards. But today we have about 5 students who are presenting their idea here. So I welcome all of you to this event. And regarding the IEEE Innovation Challenge, this is an annual event. This is going to be an annual event to be held at International School of Photonics for presenting their ideas that utilize optics and photonics to create innovative products, applications, and technologies. So this is at a time when the IEEE, in association with ISP, is coining the idea of starting a innovation hub to connect the startups and entrepreneurs in this field to the department, to the ISP, where this photonics is taken as a very serious academic program in the country and in the state specifically. So this program will be modified accordingly in the coming years, so that any person who uses optics and photonics based technologies and ideas for starting their career or some entrepreneurship or developing some devices, products, etc., should be able to participate in the coming years. So that is my suggestion. So today, in order to evaluate this program, we have Dr. Suresh Nair, who is the chair of IEEE India Council, who has encouraged all the activities of IEEE Photonics Society Kerala Chapter, and who has been coordinating all the programs that are organized by IEEE Photonics Society. And I am glad that the IEEE Photonics Society has funded two major programs like Women in Engineering program, in which $1,000 was sanctioned by the IEEE Photonics Society for training the women members for leadership in this area. And the second one is a $2,500 funding for outreach programs that was also announced last year. So I congratulate all the efforts taken by Binu Jiju, the Secretary IEEE, as well as the Student Chapter IEEE Photonics at International School of Photonics for making all the efforts to get this fund sanctioned. So I welcome Dr. Suresh Nair to this program, that is, who is the IEEE head of the country, and who is taking a lead role in motivating all the IEEE members, and especially the entrepreneurs in photonics. I welcome you, sir.
Thank you.
I welcome Dr. Sam Thomas, who is the Dean of the Faculty of Science, CUSAT, and also the Director of the Center for Innovation, Technology Transfer and Industry Collaboration, CUSAT, for evaluating this program. I mean, the presentations that is going to happen here. So I welcome Dr. Sam Thomas to this event. Dr. Pramod Gopinath, Director ISP, who is also a senior IEEE member, is here. So I welcome Dr. Pramod Gopinath to this event. Dr. S.K. Srinivasan Nair, who is a guest faculty here at ISP and an experienced person in developing high-power lasers, who is also here to evaluate these ideas. So I welcome Dr. Srinivasan Nair to this program. I welcome all the faculty members of ISP, students, MTech students, PhD students, and MSc students who are here to make this program a success. I welcome all of you. And I welcome all the participants who are going to present their ideas here. So with these few words, I welcome all of you once again to this program. Thank you.
Thank you, sir. The four participants selected to present their ideas are Mr. Pranjal Nobel Mukherjee, MSc Integrated Photonics student, ISP. Mr. Safi Sulaiman, graduate from Amaljodi Engineering College. A team consisting of Abel Punnan, Arvind Sridhar, Ashwin Ashok, and Amal K. Roy, BTech students from Adishankara Institute of Engineering and Technology. And lastly, Lakshmi M. Hari, Research Scholar, Adishankara Institute of Engineering and Technology. Each candidate will receive 7 minutes to present their ideas, followed by an 8 minutes of Q&A session. So firstly, let me invite the first contestant, Mr. Pranjal Nobel Mukherjee, MSc Integrated Photonics students, ISP, to present his idea.
Good afternoon to one and all. Am I audible?
Yes, please. Yeah.
So I hope the screen is visible to you.
Yes.
Putting it in the presentation mode. Yes. So what I'm going to speak on about today is Selenium Nanowires. So I'm a 7th semester student of ISP CUSAT, and currently I'm a visiting research intern at LANSPE, IISc Bangalore. So yeah, let's go ahead. So the presentation outline would mainly comprise of how do we prepare our sample, and what are the studies we do with our sample, and what is going to be the future course of action, which will obviously be the heart of the idea proposal. So yeah. So we referred quite a number of literatures, but the major literature which we followed for this work is displayed on the screen. And so why selenium? So selenium indeed has a very strong absorption range, absorption in the visible range. It exhibits good photoconductivity in trigonal crystalline phase. And there are variety of selenium based compounds we can see which are used for photo detecting and photovoltaic devices. We also know crystalline selenium has excellent piezoelectric properties, and amorphous selenium is used for X-ray imaging. Now, selenium is extensively important because it is a kind of an elemental semiconductor, and as well as it is an essential element in biology and chemistry. It is essential in human trace elements and many other biological applications they have. So actually selenium nanomaterials have been prepared by various techniques such as hydrothermal route, chemical vapor deposition, sonochemical approaches, refluxing processes, cellulose directed growth. But what we actually do is we will employ thermal evaporation followed by sonochemical treatment. That will be the nature of our work. So now let us go on the preparation of the selenium nanowires. So as you can see, what is displayed on the screen is a thermal evaporator. What we do is we do thermal evaporation on glass. I will show you a pictorial representation of whatever I am speaking, followed by treating the sample with propane 1-ol. Then we keep the sample in dark place for 48 to 72 hours, and then we can see the growth of nanowires under microscope. Now, let me explain what I said with the help of a photo in the later slides. But now, firstly, why propane 1-ol? Everyone must be thinking about why this chemical we are employing. So propane 1-ol as a solvent modulates the anisotropy of the surface energy, favoring the growth of highly anisotropic crystals elongated along their trigonal axis. So what we do basically is we propose a mechanism in which sonication induces and accelerates the nucleation due to enhanced mobility of selenium atoms. This will be basically employed when we isolate from the cluster of nanowires. Selenium atoms dissolve in the solvent are more energetically favored to attach to the crystalline nuclei. Nanowires grow at the expense of amorphous matrix. And lastly, nuclei readily grow into high aspect ratio nanowires with trigonal phase along the 001 direction, because the solvent exacerbates the anisotropy of surface free energy of prismatic and basal planes. Now, whatever is there is basically taken from the literature which I mentioned previously. So now the figure I was actually telling about, now this would actually make more sense, see, this is our glass plate in which we use thermal evaporation and selenium gets deposited. Then after the deposition is done, we soak it into propane 1-ol, the figure number 3. We keep it for 48 to 72 hours, and then we can take it out and we can see the nanowires are actually formed. This sonication, the process number 2, we will employ when we do the when we isolate the nanowires. So now let's go ahead. So this is actually the microscopic image, 100x magnification of the selenium nanowires. This is how it looks like, the selenium nanowires. Also, a couple of things: the thickness of the deposition which we deposited was 100 nanometer, and the rate of the thickness was 1 angstrom per second. So yeah, let's go ahead. So now our second objective was to isolate a nanowire. Then only our objective will be fulfilled. So as I told, how we do isolation is we do sonication. So what we do, we employ this the nanowire which is formed in a glass beaker. The sample is kept in a glass beaker. Isopropanol is added to it, followed by sonication, and then we can pipette the solution and keep it in a glass slide, and we can check and see that single nanowires is formed. So as I was speaking, this is a screen. You can see individual nanowires. I have a range of nanowires ranging from 22.26 micrometer to 55.76 micrometer. This is the range. This is in 50x magnification of the optical microscope. So we can see we have isolated the nanowire successfully by the sonochemical treatment. Now, the idea of our work now is we have nanowires, we isolated the nanowires. Now we will perform the SHG and THG studies followed by the electric field characterization. Now, these terms would make sense when I am actually proposing in the end what the application will be. So I would not spend much time here because there will be many images. We can see this experimental setup of the SHG THG studies. This is the experimental setup, and then let's go directly to the results because there isn't much I should speak of in this experimental setup. So this is for the bulk nanowires. This is actually a polar plot we are seeing. This is the intensity along the radial direction, and the degrees which you can see is the degree of the polarization. Let me explain about this graph. This is nothing but just the pixel. This is bulk nanowires, and THG we are performing at 1550 nanometer. So this is the bulk nanowire THG at different polarization from the nice thing about this photos is like at 0 degree and at 180 degree we are getting same kind of things, and at 90 and 270 we are getting same results. Now let's quickly shift to the bulk nanowires SHG. Again, the SHG plots are there on the screen. This is again also a polar plot. And this is also done at 1550 nanometer. Bulk nanowires SHG at different polarization. Again, from what we can see at 0, we are getting at 180, and what we are getting at 90, we are getting at 270. This is not interesting. The interesting thing now this is the isolated nanowire plot, and now let me shift again to the next slide. Now, what the interesting part is, what we can see at 0 and 180, we are getting T and 270. So let's go to the SHG now. Now we perform the SHG at 1550 nanometer, and what we see is now we are getting at 0 and 180. So this is a very peculiar thing. What exactly we can claim it to be like this, like the SHG and the THG are orthogonal and are function of polarization to each other. So this is where we have a present day it is a question we need to address in this work, like why is this happening? Maybe we need to do
Ranjal, your time is over.
Hello.
Hello.
Yeah.
Your time is up. So you have to register.
Hello.
Jury.
Hello. I cannot hear you. Give me within 2 minutes.
Hello.
I'll wind it up. Hello. Within 2 minutes, I'll wind it up.
Can you please conclude?
Yeah. I'm concluding it soon.
1 more minute. We need to move on to the Q&A section next.
Okay. I am finishing it soon. So this is a present day problem of why THG is orthogonal to SHG, which we need to address. Now, when we did some simulation results, we found out that the specific scattering cross section is obtained at 800 nanometer. So we have to check it again at 800 nanometer, this SHG and THG, not at 1550. Now I'll quickly come to the electric field characterization. What is happening? We have two electrodes. We are putting this isopropanol, that chemical which we had where the sonification happened. We'll pipette it and drop it in these electrodes, and we'll apply a particular voltage, and we will see that the nanowires are aligning itself. So what is actually happening when alignment is happening? I have a video, but I would not spend time in showing that because time. So yeah, so let me come to directly the application part. These nanowires will get aligned when we have, this is nothing but the process of dielectrophoresis, not exactly dielectrophoresis, but it's a special case of dielectrophoresis. Now they have aligned, we will take them out, and they will continue to remain in that alignment they will continue to remain in the alignment. What we can now do, once we have this cluster of isolated nanowires, we can transform them into couplers, which can be used in photonic and optical circuits. Not only that, if we have 3 electrodes, as can be seen in the screen, and if 2 electrodes can be used of alternating polarity and we can change it continuously, we will see in this liquid state they will actually align itself always change, through which we can demonstrate the switching action of the nanowires also. So let me conclude, among many applications of selenium nanowires, it can be used as couplers, waveguides, switches, and gates in optical or photonic circuits. Additionally, this is a typical lab method. Everything is feasible with the necessary equipments and chemicals. Just one health hazard: necessary protocol should be followed while handling selenium. Thank you.
Now we'll have a Q&A session.
Yeah, sure.
Yeah, I will go ahead. Yeah, Pranchal, good presentation. I have a few questions. Like,
Yes, sir.
This looks to be an R&D rather than an innovation or anything. So, can you define what is the innovation from your side on this one?
Sir, the innovation is that till now it has not been reported that nanowires can be employed as of a optical analog or optical analogus of any kind of switches. So this is one application, and what I actually said about the coupler thing, this is actually also new. We do not have any kind of application as such reported in literature.
But do you have any preliminary results or anything like that? Because
yes, sir. All these THG and SHG results which I showed you is actually done. This electric field characterization is also done, and we have some research problems as this research was progressing. So those are nominal and can be if we have if I'm provided with enough time, then we can get over that.
Okay, let me ask a little bit a different question. Like, if I make a 3dB coupler using this technique, so how will it be better than the conventional 3dB coupler? When you come up with a new product, it has to have some advantages, right? So what is the that one you are saying?
Sir, to be honest, I have never did a comparative study on that.
Okay.
But the thing is, I was more fascinated about how how my method is new. So I never had a comparative study on that.
That is very good idea, which has to be explored. My last question, I think other experts are there. One is like, you have shown all these nanowires getting illuminated, right? That is what I have seen.
Yes,
illumination happens when there is some scattering, right?
Yes, sir. Yes, sir. Sir, actually, the thing is the image. Yes, sir. Sir, I totally get you. The image which you were seeing is basically in a dark field view. That is why they were appearing to be like that. If I show you a bright field view of image, they will be normal. There won't be as such kind of
dark field view only. When it is emitting light from side, that means it is not really properly guiding, right? That's what I can ask, right?
Yes, sir.
If it is properly guiding, only at the edge you will have at the end.
Yes, sir. Yes, sir.
Throughout. So that means there will be a lot of loss. That's what I'm just asking. My last question.
Yes, sir. They can be actually this is under process, so we never actually are working towards the application side. So we are just towards the manufacturing side. Once we develop it as an application, then obviously we will have to rectify about where we are incurring losses and how do we make it more better.
Yeah, nice presentation, Pranchal.
Thank you so much, sir.
Hello.
Yes, sir.
Yeah. So I just have a few questions. So you said that you have made some nanowires by thermal evaporation techniques.
Basically. Yes, sir. Yes, sir.
So thermal evaporation is basically a low energy process. So especially when you have a metal which is deposited on a glass substrate, the addition will be very poor.
Yes,
and
sir.
Then you are dipping it in some liquid and then you are doing ultrasonication. That means your entire film will be peeled off the substrates.
Yes, sir.
And I was wondering how to get these nucleation sites instead of peeling off the entire film from the glass substrate. That is one question.
Yes, sir. Sir,
another,
actually,
you can answer.
Sir, actually, the thing is when we deposit it with many samples. So we do it with around 10 or 12 samples. So if in sonication 1 or 2 samples get destroyed also, there is no harm actually. We will have many other samples to perform the same work. So Yes, sir. I
So
do
basically,
understand.
it's a random process. You
Yes,
cannot
sir.
ensure.
Yes, sir.
Okay.
Yes, sir. Exactly, sir. Yes, sir.
Okay. And another one, you mentioned in your presentation that you used optical microscope.
Yes, sir.
Was it optical microscope or
Yes,
electron
sir.
microscope?
Sir, it was an optical microscope, sir.
And how is it possible with optical microscope to characterize nanomaterials?
Sir, no, for
Don't you have the diffraction limit effect?
Sir, for this what was the electric field characterization, we use the electronic microscope, but for seeing these
Not
images.
about the electric field characterization. You have
Yes,
shown
sir.
us some images, right?
Yes, sir. This one, right?
Not this
No,
one. Some
the
light
starting.
images.
Yeah,
Yeah,
this one.
previous. Yeah,
Yes,
this one.
yes,
Is it
sir.
an optical image or an?
Sir, this is an optical image, sir.
Optical microscope, what resolution can you go up
Sir,
to?
I can go up to 100x resolution in this microscope.
No, not about 100x. What about the typical size? You mean the dimension or the diameter of your nanowires?
Diameter, sir, our glass sample was anything between 5 into 5 millimeters. So we did
No,
deposit.
that's your glass substrate, but
Yes,
what
sir.
was the thickness of your nanowire?
Nanowire. So nanowire thickness was, we deposited 100 nanometer.
100 nanometer resolution,
Yes,
you can never achieve with an optical microscope.
Sir, I deposited 100 nanometer. I am actually not getting what exactly you're saying.
There is something
Yes,
fundamentally sir. Which questions your
yes,
characterization. Then.
Mm-hmm. Mm-hmm. Sir, this maybe I have to check with the specification of the microscope, but anyways, it's an optical microscope.
I just have one question starting off from where Dr. Suresh Nair sir left.
Yes, sir.
Innovation, as you know, has two parts. One is the invention part of it. The second is a commercialization part
Yes,
of it.
sir.
And probably you're talking about the invention. That is, I'm not a domain expert, but I appreciate that. It was pretty well done. Now, where do we go from here? I mean, I'm not able to understand the road ahead. In terms of commercialization, you
yes,
did not
sir.
speak about it. Editors are also was asking, how do you justify this in terms of either enhanced features? Why should somebody who is using an existing, method for, your switches or, waveguides or whatever, why should they switch over to this technology? One, does it offer extra features or does it offer a reduction in cost? Or how do we go ahead from here?
Sir, from here is that we have two applications which I suggested. So those applications can be studied and maybe, yes, sir, that's what my next course of action will be. And apart from that, how do I do a comparative study from what was actually existing in the market and how my things are better? So till now we haven't reached that stage. So that's why I did not. What is
to be done according to you? What would be probably your work for the next 6 months or 1 year?
Sir, so what
is that you want to do?
Yes, sir. My next work will be to carry on this research ahead, and we have these existing SHG-THG studies and electric field characterization. Now we will convert it into application. What I was actually showing you right now, this one, what is in the screen, I will actually work ahead to make switches based on this technique and couplers based on this technique. So this is my roadmap ahead.
Okay.
Yes, sir.
Thank you, Mr. Norman.
Thank you, ma'am.
Now, let me invite the second contestant, Mr. Safi Sulaiman, graduate from Amaljyoti Engineering College and currently working in Wipro Technologies, for the presentation.
Hello, sir. Can you hear me? Hello.
Yeah, we can hear you. Can you put up your slides?
One second. Can you see my screen? I'm having some issues with my computer, so I thought of using my
mobile. Huh?
Yeah, I'm using my phone. Can you see the screen?
We can see, but it looks like a mobile screen.
I'm sorry, sir, for the inconvenience. The laptop just gave up on me the last time.
Okay, go ahead then.
Okay, so the idea is simple. It was part of our BTech final year project. We aim to create a portable Raman spectrometer using which was to be cheap and with having minimum resolution problems. So we found out that a similar structure was observed in an equipment called OPU, optical pickup units, which was used in DVD drives and computers to sense the data from the DVDs. So
Excuse me.
the, hello?
Yeah, could you please rotate your phone so that it is much more would be clearer.
Okay. It's okay now?
Thank you. Yeah.
Right. This is better.
Okay, okay. So, okay. So first step was to create a portable Raman spectrometer using optical pickup units. It had a similar structure that of Raman probes that were used in conventional ones, looking like this. So we thought of using it as a cheaper version of the Raman probes to detect some pure compounds like benzene, naphthalene, anthracene that gives better Raman signals, even though it has a low resolution. For that, we purchased equipments like laser diodes, which were cheap and giving out around a watt of 100 milliwatt. And we use green laser that was 532 nanometer as an excitation source to avoid fluorescence effect. Now this is what the OPU looks like. Inside the OPU, there are optical chambers that had similar properties of Raman probes. Like when we use an excitation source and use it to excite a sample, the light from the laser gets deviated by a 90-degree and hits on the sample, and after excitation, the sample source is collected back to the optical pickup unit, and it was relayed to an optical fiber at the top. Now these were the 3D printed parts that we used in the first experiments, and we used a filter called optical edge filter. It's a 532 nanometer edge filter which was used to reject the wavelengths which were less than 532 nanometer. In order to suppress the noise that was caused by the excitation source and to filter out the remaining stroke lines of Raman spectrum. We use collimator lens, but during a phase 1, we couldn't get that much result as anticipated because of spectral resolution problems of a spectrometer that was thunder optic spectrometer. It had a resolution of less than 1 nanometer. So the software we used for interfacing was a SpectraGriff software, which was capable of detecting peaks from the with the interface of a spectrometer. Now, the reason we use green laser was its benefit of producing low fluorescence effect and all. So we tested on some compounds like toluene, but the graph we got was not that satisfactory. We also tested on naphthalene. We also got, but the results were comparatively very inconsistent. So for that, we switched on to phase 2, which was using a method called transmission method. Actually, in the first method we used were backscattering method. The backscattering method can only be used for solid samples like naphthalene powder and all. The results were very inconsistent with respect to transparent solvents. So we tried to use the transmission method using the optical pickup unit. The structure had used the same optical pickup unit as the collection for the excited waves of Raman spectrum. This is the diagram of the 3D printed part along with the OPU we used. This is the placement of optical edge filter over it and the laser source that we used. Now, as the hardware part, we used various optical fiber and the same thunder optic spectrometer. And these are the parts we 3D printed in order to get in order to work out this project. Now, this is the basic working method. Now, coming to this part, the results were pretty much better compared to the previous ones because the samples were basically pure compounds in a liquid state. We were able to get some results, still inconsistent, having resolution problems using this method. Some of the results we tested for compounds like acetone, these were the results we got, but still inconsistent. We took the data from the internet as a source because at that time we didn't have some to use the help of institutes to verify. The signals were pretty inconsistent. Now this was the end of phase 2. Now coming to phase 3 was we aimed at improving the resolution. So phase 3 was to replace the spectrometer. and replaced with the DSLR camera, which had high-grade CCD sensors. So this had a pretty good effect on our research work, because this was we had a base paper actually. So we actually combined it using our previous methods, like using the optical pickup unit. The optical pickup unit has some advantage because it had a optical voice coil motor, which can be used to adjust the focus of the optics. That was a main advantage for getting the result in the third phase. Same model, same light source, same optical fiber. We used HDMI capture card to get the image transfer from the DSLR camera to the interface, that is a Spectrometer software. And we used diffraction grating setup, which was created by us only inside a box using a diffraction grating film. It was around 7,500 lines per millimeter. We 3D printed some of the models like the boxes. And we used Origin Pro to construct the data to a graph. These were the algorithm and working of the project. And coming to the results, and this is the setup that we used finally using the optical pickup unit. Because of the high resolution of the cameras of DSLR, we were getting pretty good results. Now this is the spectrum that we got for benzene. We compared it with the values from the internet, which were comparatively similar. We had some shift in the values and that corresponding peaks, but we were getting pretty good results compared to the previous versions. This was the spectrum that we obtained for naphthalene. And the spectrum of toluene. Thank you. I like to add something, like this was actually a research-based project. Our aim was just to analyze whether the optical pickup unit, which was a cheap element, could be used to get a Raman spectra in a small laboratory-based setup. Thank you.
Yeah.
Let's move on to the Q&A session.
Yeah, Safi, very excellent presentation. I have a few questions, like you have presented in a nice way, like phase 1, phase 2, and phase 3. So a few questions like, did this optical pickup unit really help you? That is only auto-focusing you could do, right? Using that?
Yes, sir. The optical pickup unit had some structural similarity of the Raman probe. Like it could transfer the excitation source to the sample and excite it and collect that signal from it backwards. So,
okay. So that structure you used it, right?
Yes, sir.
Like a rectangular thing, and it falls on the sample and all. Okay.
Yeah, the working principle.
Okay. Otherwise, what are the other things you have used? Because I have seen you yourself using a grating, then say a spectrometer, then
Yes,
laptop, and all those things. So,
yes.
Did it really help in achieving a low-cost spectrometer here, Raman spectrometer?
Sir, I would say the last phase, that was a phase 3, would be a considerably good achievement compared to the previous ones, because the previous ones we were having a lot of resolution problems. We were getting graphs, but because inconsistent.
Okay.
But coming to the phase 3 part, instead of using the thunder optic spectrometer that was having a less than 1 nanometer resolution, the DSLR was able to pick up major peaks and identify them. But the problem is the DSLR cameras are highly expensive.
That's right.
Yeah. So we couldn't achieve the part that was constructing a low-cost Raman spectrometer, but we could verify that the optical pickup unit would be a viable replacement for Raman probe setup, like verifying its principle. But we are confident that in the future, if we develop ourselves some use the customized CCD sensors to capture these images or these signals, we might be able to construct them within the cost that we anticipated.
Yeah, there are some small modules available, like a spectrometer and all, So
yes, sir.
Yeah, that may be a better way, so that you can even give a optical fiber as input, and you can get all the digital signals, like pixel weight versus the the wavelength. Okay.
So the idea was actually in a product way, we imagine that why don't we create something specified to a product? So we don't need to increase the wavelength of the.
Okay. Okay. For example, you want to see only whether benzene is there. That's way, right? Instead of looking at the characterization. I got it.
Yes.
I got
So
it.
I believe that it can be scaled up to a product level for a specific.
Yeah, that is good. Safi, can you think of an innovative application for this one? Because all other things now, whatever you have done is sort of a standardization, validation. You know, like whether my system works, because you know what is the peak for all these things, and you are cross-validating. But when you talk about a single wavelength, that's a good application. For example, explosives and things like that. You know.
Yes, sir. RDX.
So, what is your what is the application you have in mind? Like, if I ask you to develop it as a product.
Sir, according to us, we wanted to develop this into a state where we could identify pesticides in soil, but because of the resolution problems, we won't be doing it. So we thought of studying the quality of pure solvent compounds like carbon compounds, like anything related to crude oil or pharmaceutical industries, to verify the quality of that typical product only.
Okay. Yeah, my last question, like you mentioned, even when you did the validation, the peaks were not really matching with the literature, the reported results. You know, what can be the reason? Where can be the issue? Is it with your pickup point or filter or your spectrometer, the camera, or your software?
Sir, the issue that in the final phase 3, we observed that there was a shift from the Raman peak. The peak was showing it, but there was a shift.
Yes.
We believe there's something that is caused by the optical pickup unit or the materials used in it. Like, for example, if we use the cuvette instead of the sample analyzing part of the glass base, we might get a better result.
Now, are you coming to the point saying like I will not use optical pickup unit?
Actually,
that is the whole purpose, no?
Yeah, it's the main point actually, but we don't know, sir. It might be due to internal materials that was used inside.
Okay. Okay. Thank you. Thank you from my.
Thank you, sir.
No, I just wanted to clarify based on my understanding. This you are positioning it more like a relatively, cheap spectrometer. May not be very accurate though, but then serves the purpose. Is that would be a good positioning? Because in the market you need to position your invention, right? Because I'm sure you are not taking on the most accurate spectrometers. You are not betting it on the accuracy or the resolution, right?
Yes, sir. We are just more concentrated on identifying a typical quality of a single product and
one compound. But some of the applications you pointed out, like the pharmaceuticals and all, do you think? Because I mean, as far as I understand, these are the people industries where higher focus on the quality and accuracy. So, which kind of industries you think will be interested in your product when you position it as a cheaper but not so accurate instrument?
Petroleum industry, sir, like the analysis of crude oil or anything related to those kind, because that should not compromise the. It should not affect the people like that quality directly. If you are based on pharmaceuticals, the malfunctioning of the device might affect.
Yeah, that's why I was thinking when you mentioned the pharmaceutical earlier. So I was thinking, but do you think industry will have takers when you say it's not so accurate, but then, what percentage, I mean, what do you think of how much it could be cheaper compared to an existing higher end spectrometer? What could be, the price in terms of how cheap it could be, at least in percentage terms?
I believe that we can improve this efficiency by using machine learning models and comparing with other known
we are looking at the existing model.
Yeah.
How will you, that is the one you're presenting now.
Within, right? Sir, currently we were able to make this under 2 lakhs. If I mention the price of DSLR, but I believe it can be optimized too, because if we are developing our own sensors. The market, we believe it's between more than 10 lakhs to 7 lakhs and plus later to with respect to resolutions. The price of spectrometers are pretty high.
No, but the petroleum industry, as you said, is I mean, it's a cash-rich industry. There are a lot of money. So do you think they will save 2 lakhs, for accuracy? They will, compromise accuracy for 2-3 lakhs. Are we betting on the right industry again?
I guess it's a no.
Yeah. So, I mean, so this is, I'm talking purely from the business perspective.
Yeah, I understand.
The right positioning of the product and identifying the right customers based on your skills or rather your strengths of the product becomes very, very important. I mean, that is the only point I was just trying to put.
Yes, sir. Actually, when we started this project, we were aiming for getting the results on like taking the results in a place where it's totally isolated from labs and all, like a real time. That's the idea. The idea was the portable Raman spectrometry. We should get the results ASAP from that current location. But when we came across the resolution problems, we had no choice but to shift to other. We had to look forward for other related fields. Actually, the main idea that I came here was getting a good feedback here. Like the main idea I currently I'm presenting here was to get the better insight onto this spectrometers and related stuff, because it's actually pretty rare to find people having some specialization in these fields. And it was I faced many challenges because of lack of resourceful people within this field while constructing this research work.
Okay, ISP is the right place. Okay.
Thank you. Thank you.
School of Photonics. Yeah.
Okay. I have two questions. One is actually the extension of the previous questions by two persons. One is the commercial production and application of this one. How confident you are about the commercialization of this one? And second one is the technical one. Can you extend the application to soil analysis, like you mentioned about pesticide analysis in the soil? So is there any possibility to extend this to other soil micronutrients and that type of things, so that it can be made use of by many persons, especially in India? The soil analysis still in the laboratory level. Most of the farmers are not utilizing the application of the soil analysis because of the tedious work. So what is your opinion about the commercialization of this product, your expectation? And second one, extension of the application for more applications like soil analysis and so on.
Sir, while we were working on this project, we actually considered it as the first step was to create a product that was to do soil, identify fertilizers or pesticides in soil. So while doing this, after the phase one, we were pretty we were pretty sure that we won't be able to do it with this kind of resolution. But looking on to more research, we found out that there was a method called SERS, surface enhanced Raman spectroscopy, but it involves some specific chemicals which were used to enhance the Raman signals that were given out by the sample. Like I believe it was silver nanoparticles or something which were used and mixed with the sample to produce more Raman spectrum or kind of amplification of the signals. So we were also thinking on getting onto it, adding with this prototype. I believe that it would provide a solution for the testing of soil samples, because the elements present in the soil will be in parts per million, and also this amplification method might give a boost. Sir, what was the second question I missed?
Hello.
Hello,
okay.
sir.
Actually, the first question, that commercialization of this product.
Commercialization of the product. Sir, by the phase 3, we were sure that if we are able to make something that is a specific CCD sensor used for the detection of a specific compound, we will be able to cut the cost relatively very lower compared to the DSLR. So we were planning to build up within a box setup which was able to analyze a sample inside that using the same wavelength laser 532 nanometer, detection of a specific compound. So also incorporating machine learning models to improve its efficiency. So if we are able to customize the DSLR part, that is the camera CCD part, and make it in a cheaper version, I believe it can be upskilled for a commercialization. But application is something that we haven't yet decided. That's a bit tricky part. Like, so as Sir told before, like why would petroleum industries want to compromise with the quality and all using cheaper equipments?
Excuse me, we have run out of time.
Okay.
So, thank you, Mr. Safi.
Thank you. Thank you, sir.
Up next, we have a team consisting of Abel Punnan, Aravind Sridhar, Ashwin Ashok, and Amal K. Roy, BTech students from Adishankara Institute of Engineering and Technology. I invite them to present their idea.
Hello.
This is okay. I think this is different, right?
Sorry, ma'am.
This is different team. I think now we are calling Abel Punnan, Arvind Sridhar,
Ashwin Ashok, and
Yeah,
Amal
yeah.
K. Roy.
Yeah.
Ma'am, can you hear me? Hello?
Yes, yes. Please go ahead.
So what about the video? Is it visible? PPT.
Perfectly.
Okay, sir. Okay. Good afternoon, all. We are from Adishankara Institute of Engineering and Technology, and we are now currently continuing our degree in Electronics and Communication. And Abel Punnan, Amal K. Roy, me, and Ashwin Ashokan are the team members. We are here with our simple project, ceiling fan automation. Just a second, ma'am. Our problem statement is that we are mainly focusing in order to save electricity and to save the planet using optical components. As briefing our project, all you know that there are many fans in colleges, auditorium, public stations, etc. and all. Due to carelessness, many of the fans are continuously working without any human in that hall or nearby area. So it may cause electricity wastage to the amount. And as an considering example, this is a real scenario in our institute. This photograph here shown is our classroom. You can see that many of fans are working continuously without any students in the class. And if we consider the auditorium of our college, there are totally 150 numbers of fans running continuously for 10 hours, and about 40% of the energy is being wasted. So for an year, our college has been a loss amount of 70,000 rupees. We are only considered the fan, not lighting and air conditioning, and other devices are not considered. Only the fan is not considered. And how can we make a solution for that? We are making the fan automatically. That is automating the fan. So you will ask how it is possible. We are using an IR motion sensor to switch on or off the fan. IR motion or PIR sensor. And this is just an example for that. Whenever a person comes under the sensing area of the PIR sensor, the sensor connected to the board will give a message to the relay, and thus the relay turns on and off the fan simultaneously. And you can see that this is the IR sensor we are using, PIR sensor. And example, we are using a real-time example of a product. While the first picture shows that the two students are entering the classroom, on that same time the fan is switched off. So under the sensing area of the PIR sensor, the sensor detects the motion of the two persons sitting under the sensor and automatically turns on the fan. So the fan gets automatically on and off. There is no manual operation is needed. And coming to real-time example of a product, while two persons are leaving the hall, you can see that two persons are sitting under the sensing area of the fan, and the fan is being gone on. And whenever the students try to leave the classroom, the sensor detects that there is no motion of the student, and thus the fan get automatically turns off. So if we forgot to turn off the fan while leaving the classroom, it will not make any loss of electricity because our sensor will automatically sense the motion and control the fan and all. And this is a circuit diagram we have done in Tinkercad. You can see that we are using an Arduino board. This is an Arduino Uno and PIR sensor, a relay module, a DC motor we have given as to simulate. Coming to the real project, we will replace the DC motor with a wall fan or ceiling fan, and a 9-volt power supply has been given for powering the relay. And the green square-like shape you have seen, that is our PIR sensor. So as I told earlier, when a person comes under the detecting range of the sensor, the sensor detects about 10 seconds where there is motion or something in that area, then it will automatically give a message to Arduino. The Arduino connected with relay switches the fan as it will either close the circuit or on the circuit. So if the motion is detected, the fan will automatically get on. If there is no motion under the sensing sensor, there will be no automatically working of the fan. And this is a hardware implementation we have done in our college. As you all see, the same components we have been used. This is a PIR sensor and a 12-volt DC motor has been given. And coming to conclusion of our future work, we almost completed automating the fan circuit, and the total approximation or the total cost we have used is rupees 600. As we are now using an Arduino board, so it will make 600 rupees. When we replace the Arduino board with ESP8266 module, the cost will come to an amount of 550 or 500 rupees. And next we are focusing on automating lighting and AC. Now we are only considered the ceiling fan and miniaturization using microcontrollers. As we researched or looked at the internet, we can see that there are mainly 24 crores of houses in all over India. Each and every house contains either 3 or 4 fans compulsorily. So when we use this product, or when we use this product in the ceiling fan, it will make a very big sense that it will save the electricity to a certain, and by not only the houses like auditorium, like public stations, like railway stations, college classrooms, every halls and every rooms using more than 2 or 3 fans can use this, and having individual fan can also use this. And the references we have been used from the net is these 3 papers. Thank you. And this is about our project.
Thank you. Now let's move on to the Q&A session.
Yeah. Abel and team, good presentation. But what is the innovation part you are explaining? Because this has been there for quite a long time. We are using the motion sensor and all those things. So, what is your innovation from your side? What is the contribution on that side?
As I have said that this is a simple product. We are always having the sensor fans, or using the fans we have automatically work with the remote and controls. We are mainly focusing in order to implement this product in the existing fans as from the.
Okay. So where will you keep the sensor? That's in the fan, ceiling fan.
So basically we have planned to make a cover like thing. As the same shape. If this is the fan leaf, we are using a cover like shape like this. So the sensor will be under this fan. So it will not have any motion or something.
I did not get that one, because the fan will be rotating, right? So where will you keep the electronic circuit, and you have a little bit circuit also, right?
Yes, sir. The Arduino board, relay module, and the relay.
Yeah. Where will you keep physically?
Inside the cup of. We are implementing the 3 components in a small square-like box, and square-like box is being used in the cup of the box, inside the cup of the box.
Cup means top.
Yes, sir, in at the top.
So will it be able to sense the person moving down?
Sir, the sensor is being given under the fan. If the fan is been rotating like this, the sensor is being under the fan, like a stand given in below the over the leaf of the fan.
Okay, so that is one. I think that is one aspect. Second one is many people, even in my home, there are some motion sensors, but I keep it switch off. Lot of false triggers, So did you do any work on that one? How to avoid false triggers? Because when you are not there, also it can happen. Like the fan will be running the other way, like the whole night it may be running due to false trigger. In these type of motion sensors, right? Otherwise, you have to come up with some different innovative method, algorithm, and things like that.
Different innovations have been not being used. The existing ideas have been modified and been implemented in our product.
Okay. Thank you very much for the presentation. Yeah, but I think you could have made a small box and shown, in the fitted in the fan, so that that because this is a breadboard, I think within 1 hour we'll be able to wire it up, right?
Basically, our guide has been told yesterday. He was having some.
Okay. Go ahead. No problem. I just commented.
Hello, can you hear me?
Yes, sir.
Okay, my questions are very simple. When you if you do a cost comparison of an ordinary fan and the sensor implementation and all the things, you told something like rupees 500, 600 itself. That itself is a comparatively huge cost compared to the price of a fan. But the second one is that, as Dr. Suresh has asked, incorporating all these things in a fan with all these facilities, sensors, and all the things, I don't think commercially how much it will be feasible. And the third one, again, the repetition of the sensor, reliability of the sensors, and that type of things. So if you put all these parameters into account, I doubt whether such a product may be commercially feasible or not. That is my first question. Second one is that regarding these sensors, connections, and all the things, it add a lot of complexity, unexpected complexity, and all the things. Have you ever thought of addressing those type of things in the actual implementation of this product? Okay. Can you hear me?
I think you are muted. Yeah.
Sorry, sir, I have lost my connection. That way I got rejoined. So unmuted.
Did you hear?
Yes, sir, I am able to hear. Hello?
Yes, please go on.
Sir, I didn't hear the question because I have lost my net. Can you please?
Okay, I will repeat in simple words quickly. One is the commercial production of this one, cost analysis. Implementing the product may exceed much above your estimated value of rupees 500 to 600. And second one, the reliability of the sensors and the product.
Sir, coming to commercial production, we are mainly focusing on to make a number of products so that we can reduce the cost. And as comparing to the market, we are having Havel fans for a 1800 that will automatically works under the remote control. So while considering with that fan, if a fan having 700 or 800 rupees, either or existing fans in our colleges or in your house, every kind there will be an existing fan, so that we can implement this product for 400 or 500 rupees. So it will make commercial, sir. If we given to any or take when we have discussed with the fan companies, they have been said that if the product is being used widely or mass production is being used, so they will eventually decrease the amount from 500 to a certain amount.
What is the reliability of the sensors you are expected to use?
Sir, for our sensor, we have 3 meter to 7 meter of detection range and a 120-degree angle of detection range. And a reliability is that it will have a life of 2 to 3 years according to the environment we are using. And another protective cup is being given as the sensor, so it will make the sensor durable for more and more long time.
Okay, that's all.
Yeah, Abel, just to add on sir's question, in the product you showed, we have to use 9 volts battery, right?
Yes, sir.
So this also has to be derived from the fan connection, right? Then you need to have another AC to DC converter. All those things you have to consider, right? When you consider the cost, because nobody is going to change the battery and the ceiling fan. That will become more issues.
Sir, instead of 9 volt, just we have been given 9 volt battery for a prototype. We are using a relay circuit in order to convert the 230 volt AC coming from the fan to a 5 volt DC, so that our product will work under the electricity by using the relay module.
No, but your system Arduino board or something similar has to work on DC, right? Low voltage DC, 9 volts or 12 volts or whatever. So you have to derive that one from 230 volt. Right.
So we are an alternative way that the phone charger, you have seen an adapter phone charger. So it will control or it will convert the coming high volt to a low volt for working the Arduino board or ESP module we have been using.
No, that's an AC to DC converter, right? That's what you're talking. Yeah. Okay. So all those things have to go there. So
Yes,
your
sir.
product cost will be high, and nobody will like, for example, if I'm buying a fan, I'm just giving some feedback. Okay. So when we are buying a fan, and if you do anything with the fan, the validity of the warranty goes. Okay. So you can't go back to the fan manufacturer and ask for anything. So all these aspects have to be taken care. Okay. Sorry, I got in between.
Okay, I'm extending the same question what Dr. Sureshnar asked. Actually, that was in my mind. As by some very crude estimate, the cost of the sensor plus fan will be almost a double at least when you implement this one something successfully. So 1,800 means actually it should be 3,000, or the cost of the fan may increase almost a double, come to almost a double. That is some very crude estimate in the most optimistic way.
Sir, at the beginning, I have already said we are mainly focusing in order to implement on the existing fan. So the amount of fan will not be a matter for us. Just we are using our product on the existing fan. So by taking all over India, we can see that the 70% of the fans now are working at the existing fans, and the rest of the 30% are being buying new fans every day. So while considering that percentage, it will be also a profit for us.
Okay. Why don't you also look at designing a good circuit and probably work with some local fan makers and give it to them so that they implement it while they make the fan, rather than implementing it, wait till somebody installs a fan and then you come and put it up. There are a lot of lower end brand available in the market, right?
Yes, sir.
So where this could come as a USP to them. So don't you think that would be a better idea rather than you implementing it in all fans?
Sir, I have not only in the fans, we are in future, we are making or we are planning to use this product inside the air conditioners or other electrical.
No, what I'm saying is when you have the product coming with this built in,
okay, sir,
it may be having more takers, right?
Okay,
rather than you putting it as an extra device. That was first question. Another issue could be, again, when it comes to a fan automation, unlike a light automation or a bulb, which we all do, it is not just about a binary on off. It is also about the speed, right? So you need to regulate the speed also. So it's not just about switching on or off the fan. It is also about adjusting the speed. So looking at the number of people inside the hall, I would like to set the speed. Looking at the temperature, I would like to set the speed. Temperature is another variable that gets in. Right. For example, today we are all sitting in a very, very cold environment. All fans are switched off, just although we have a lot of people inside the hall. Right. So how do you bring in intelligence with respect to number of people, the temperature kind of things also into it?
These all things we are planning to do in the future.
You thought about them?
Because we are now, this has been implemented as a mini project. When it comes to a final year project, we will all implement the temperature.
You will implement all of this
in order to control the speed, and by adding an ESP8266, we can control the fan using Wi-Fi or Google Assistant, etc. Sir, more than that, we know that the energy is being producing in India through a large amount of using fossil. So when the energy is being get wasted, it will also make the production of electricity to a huge loss. So by implementing a product, we can thus decrease the production of electricity, and by this the global warming, the fossil and the global warming are always interconnected. So
the intents is all appreciated, but sometimes as we're saying,
yes,
the market has its own way of evaluating products, right?
Yes,
So not every person buys a product worrying about global warming. The intentions are all appreciated. How do you translate that into a commercially viable product is what we're just looking at, right? Your intentions are very noble, I understand.
Yes, sir.
Thank you.
Thank you, sir.
Thank you. I think our time is up for the Q&A. Thank you to the team. And up next, so now I invite the last contestant, Lakshmi M. Hari, research scholar at Adishankara Institute of Engineering and Technology, for the presentation.
Lakshmi, can you start?
Ms. Lakshmi, can you hear that?
I think they have muted, right? Yeah. Lakshmi, are you there? Yeah. Yes.
Good afternoon, everyone. Am I audible for you?
Yeah, but your slide is not seen.
Okay, 1 second. Is this visible now?
Yeah, can you put it in the slide mode?
Yes. Sure. Okay,
Yeah.
myself, Lakshmi M. Hari. I am a research scholar from IIT Madras, and I'm working as assistant professor here at Adishankara Institute of Engineering and Technology. So here I came up with the idea of food quality detection using spectroscopic method. So before going to the details, food quality, which is actually very important nowadays because we all are foodies, we all go out, have food whenever we get time. And now we are focusing mainly on the oil content and sugar content in our food, which is available nowadays. So the oil food, which we know, it raises unhealthy LDL cholesterol and lower the healthy HDL cholesterol, which actually causes a BP variation, heart attack, and a stroke. And the cardiovascular diseases are the main prime reason for 45% of the death in the age group of 40 to 69 year in India. So from the references. And about the sugar content in the food, sugar contributes to additional calories without contributing any nutrients. And it causes diabetes, loss in weight, and the oral health issues. About 77 million people in India affected by the diabetes. That is actually 1 in 11 Indians. And furthermore, 7 lakhs Indians died of diabetes, hyperglycemia, kidney diseases, and many other complications related to the diabetes in 2020 itself. So the main reason for this is the packed food, mostly the fruit juices, soda, the barbecue sauces, which is much available nowadays. So what is the solution for this issue? That is we can come up with a measurement of oil, fat, salt, and sugar content of our food before we consume it. So how is it possible? So here comes the idea of using spectrographic method of food quality measurement. So we are using near infrared signals, which causes overtones and combinations of the vibrations of CH, OH, NH, and CHO in the food particles, as well as some other bonds can be observed in the NIR range, making it possible for measurement of various structures in the food particles. The idea is given in the picture that we are using this illumination on the sample and the detector is on the other side. Here is some of the bonds in our food particle is shown in the picture here. And in the modern NIR spectrometers are categorized as light filtered instruments, scanning monochromator instruments, and many other instruments are available. And we focus on the light emitting diode instruments. In an LED instrument, an LED is used, which is in range of 700 nanometer to 950 nanometer. It is used as a light source and is able to transform the electronic energy into radiation directly. So it is efficient, durable, and portable. We propose the transmittance mode, not any other mode. We are going for the transmittance mode. And here is the proposed method. Applying the signal on the sample, and we acquire the spectra, and from the spectra we pre-process and then comes to an optimum model. Here, the question you may have is whether this device is there already where it's existing. Yes, something similar is existing, but not developed by Indian company. It is not available in India. And you know how much it may cost when we import something in the range of 3,000 or 2,000, which is actually lakhs in Indian money. And so our plan is to make it affordable, portable device, or it can be an Android app also for all accurate and low cost, which may come like around $100, which we are predicting we can develop something which gives an output like, yes, you can take this food or don't take, according to the input of our health history, which we can feed to the device. Okay, it can be either a device or an app. So this is what my idea is about the food quality detection machine. Thank you, sir.
Yeah, Lakshmi, good presentation, but you know what is the innovation? Because this you will normally get it in any literature, right? It's a known thing. Like you use a spectrometer, you can find out what are the things are there. There are many devices also which are used for counterfeit drug measurement and things like that, even for food. So, what is the innovation you are now claiming from your side?
So something like some machines like a cup kind of thing is there available, which is not actually giving an intimation whether it is not giving a clear intimation about all the food contents like oil and sugar and all. We are planning to mostly focus on the oil content in the food and sugar content in the primary stage.
Yeah, but the problem is like you have proposed a transmittance mode, so in that case, how will you put the samples? The sample has to be so thin, right? Because you are putting a LED here and then the sample and then the detector. Look, because reflectance mode is always better. Like you can say that in a cup, in one edge I will put an LED, one edge I will put a whatever detector, and all those things you can think of, but I could not think in terms of transmitters. Can you show some light on that?
Sir, this is just a basic idea. We didn't come to that level, but we are thinking on it. We can make it possible. That is what I think. We can come up with.
No, but for transmittance mode, that may be a challenge.
Because this transmittance mode is giving more information as compared to the other.
But the sample has to be so thin then, right?
Understood, sir.
So that is like it's for sampling purpose. You can take a vada and sample a little bit, take it out. That is okay. I think that is one concern I had. And the other concern is like it's a good area. A lot of people are coming up like that. Like a cup, and I have thought about that. And there are many apps now. Before eating, you just put what is the what are you eating, that itself.
Yeah, that we do, but it is not telling
really
us how much
measured.
quantity of oil or sugar is there.
Absolutely. But it gives some fair idea. I think for
that
this
is
type of purposes, that may be enough. That's what I'm just coming to. Like instead of you have to know exactly how much it is, but the range is enough. So those aspects also please consider.
Sure, sir. Sure, sir. In the development, we will definitely consider all these concerns.
Yes, hello, can you hear me?
Yes, yes, sir.
Okay. In addition to the technical aspects as the Dr. Suresh Nair has explained, what is the commercial aspect? How feasible it is? Because even if you take for the sake of argument, $100, that itself is a high amount. Can you think that even with that cost, is it affordable as a commercial product?
As well as a primary development stage, this is what we are predicting as a device, and we hope we can reduce the budget, maybe little. When it comes in the Indian scenario, we hope we can reduce the price. This is the first estimation, because whatever is available is in the range of $3,000, and so this is something which we are predicting.
And as a product, the sensor should be more user friendly, and that type of aspects will come. How do you previously asked? How do you explain? How do you address those questions? Make it a more user friendly product.
Sir, if we are planning to either develop it as a product which is something handy, like a mouse or something that size, or maybe we will develop something as a phone app. Something similar is there in our Apple phone, which is available.
Yeah, that is what exactly I was coming to. When you say this can be an app in an iPhone, what is the market for your product?
We have to implement it in the Android. Then Android is not providing.
No, if I just said iPhone, it could be there in the Android phone as well. I mean, higher end.
And I mean, we cannot. Not everyone can afford an iPhone.
No. Don't hang on to iPhone. I just said a phone. If it is a phone app, do we have a need for a hardware? The moment, because that if the phone comes with an app, as Dr. Suresh was saying, you don't need to be knowing exact oil percentage or the sugar quantity. You just need to be more or less in the range for which most of us, including for our health measurements, we more or less rely on the health apps which are available free, right?
Yes, sir.
And also, I just wanted to ask you, whom are you targeting? Who is going to buy your product?
Oh, everyone is, sir.
No. So what I'm saying is, it meant for a household. I mean, one equipment in every household is what you're looking at.
Yeah, with every person has to carry it.
No, because I was thinking, I mean, again, as I said, that is very important, no? The positioning of the product.
Yeah,
because
actually,
I do not know if my wife is making vada, am I supposed to be checking the oil content using this? Or is it only meant for items that I buy from outside? I do not know, because household, we control, right? The sugar, the oil and all, we decide.
Still, we are not aware how much we can consume. According to our health record, you can give our health record as the input and then checking.
Okay, I was just asking, not to argue, saying these are some of the issues which become important at the moment somebody asks me to spend $100, 7,000 rupees on something whose need is not really felt, or when it is available free of cost to me as an app in my mobile. No, I always think twice before I spend 7,000 rupees, right? Or whatever. Correct. So just be aware of this fact. That is all I'm trying to say.
Okay.
All right. Thank you.
Thank you, Ms. Lakshmi.
Thank you, ma'am. Thank you so much.
Now, I request the jury to have a discussion on the completed presentations and make a decision on the winner. Meanwhile, we will have the...
Can you make other people leave? for some time, 10 minutes. Only jury will be there.
Oh, okay. Yes, sir.
Pranjal, can you move out for some time, 10 minutes? Yeah. Yes. There is some
I
more.
request the participants.
Yeah, I think only we are there. Srinivasan sir, Sam sir. So, what are the feedback?
Suresh sir, I think we'll just go to director's room, log in, because the participants are all staying back in the hall. We are also sitting in the hall.
Okay, okay.
So we will just go to director's room and log in, then we can have a discussion.
Sure,
I think
sure,
that
sure.
would be better.
Sure.
Yeah.
So Binu, are we ready?
No, sir, I will ask them to rejoin. Yeah.
Yeah. Binu, can we start?
I request the jury to announce the winners.
Okay, thank you. So, first of all, I would like to thank all the participants. They have presented very nicely and with very clear ideas. And also, I would like to thank the jury members, Dr. Sam, Dr. Srinivasan, Dr. Kailasnath, and also Director ISP, and supported by Binu Jiju. Binu and the student branch of ISP, they have done an excellent job. So a little preface for before announcing, this is basically a innovation challenge, and those who are in photonics, they will know that a lot of work has been going on in startup area. Many devices are coming up based on optical technology, but there are very less number of optical experts, who are able to support and things like that. So we IEEE Photonics Society as well as the ISP, we thought like we should create that awareness there are a lot of opportunities in many areas, including healthcare, industrial, then agriculture, in aerospace and defense, and all. Lot many applications are there of photonics or optics, whatever you call it. And we want to really encourage people to get into that. So that is the thing. See, what I have seen is like many of the people have been funded by Department of Biotechnology and other government departments to the tune of 50 lakhs and above. Those who are coming up with the devices. So many of these devices are using optical technology. So that's what I understood. So we have to whether it is a spectrometer or the fluorescence and various properties of lights are applied on that one. So that is the whole purpose. Now this time we have less number of applicants, but I am very sure with a lot of publicity next year we will have a lot of applicants. This is basically not a research paper contest. It is basically what we were looking, jury was looking was what is the innovation you have? Innovation means it's not like something non-existing you have to tell, but incremental innovation also will do. Okay, so but this should have your contribution. So that is very important. And whether you have really identified this as a product which will have a lot of applications, which will be cost effective so that people will buy. So all these aspects one has to really look at. Then only you will become successful. So the jury has gone through all these things, and I think all 4 teams are winners, but still we have to select. So jury has unanimously selected Safi Sulaiman's project, idea on low-cost Raman spectrometer using OPU as a Raman probe. So even though not much to be done on this one, but still the jury found that a lot of work has gone into that one through phase 1, phase 2, and phase 3. But still, to reach the commercial level, it will be a little more time it will take, but the team can continue work with the ISP who are experts in the optical technology, photonics technology, as well as we have CITIC, that is the they encourage or they nurture all the ideas to be translated into commercial products. So you can always approach them. They will also fund. If the idea is found good, they will also fund. So with that, I thank all the members who have attended this. Congratulations to all the team, but especially Safi Sulaiman for idea on low-cost Raman spectrometer using OPU as a Raman probe. Thank you.
Thank you, sir. Thank you. I'm really grateful.
Congratulations to the winner and the rest of the participants. Let me now request Dr. Suresh sir to give the felicitation.
I think I have covered felicitation also in that one, so I think I'm okay with that one.
Thank you, sir.
Yeah.
Now let me request Dr. Sam sir to speak a few words on the contest.
So I would like to congratulate all the teams. I mean, I'm so happy to see that students and youngsters are putting a lot of effort. Just one point I want to tell you, when we talk about innovation, always keep it in mind that this has 2 aspects. One is the R&D part of it, the uniqueness and all that. Then there is a business side to it. So innovation happens when you have the right marriage between these 2. So that is an area where all of you have to keep it in mind when you talk about innovation. Wish you all the very best. And as Suresh sir said, in CITIC, we are always there to help you. You are always free to come to the QSAT Incubation Center for any assistance. Wish you all the very best. Thank you.
I request Dr. Srinivasan sir to speak a few words on the contest.
Okay. Thanks everybody for participation and congratulations for the team. And I don't want to make any further comment, but this time this is our very small beginning. And so from next time onwards, we expect that more participants and the real idea of innovation challenge to be conveyed to our participants and at least through the Kerala all colleges and all the things. So we expect more participants and a better what is called event in the next time. Thanks. Thanks to all.
Now, let me invite Mrs. Binu Jiju, Secretary, Photonics Society Chapter, to give the vote of thanks.
A warm and graceful good evening to everyone present here. This is a momentous day in the ongoing journey of Photonics Society Chapter, as we are first time hosting this kind of innovation challenge program. So I express my sincere thanks to the director, Pramod sir, for giving us a chance or a venue and all the support for this particular program. I'm thankful to all the contestants who presented their innovative ideas here. I'm sure that you will all benefit from the experience that you gain from here. Many thanks to Dr. Sam Thomas sir for coming here as a jury member to evaluate the contestants. As a token of gratitude, we would like to give a small gift to sir.
Sir, one request, is it possible to get the participant certificates for our students?
Sure. We'll give you all the other participants will receive the participation certificate and also a welcome kit. We'll send to you.
Okay, thank you so much.
Thanks to Dr. Srinivasan sir also for his valuable comments and judgment. And as a token of gratitude, we'll give you a small gift, sir. With a deep sense of appreciation, I really thankful to Dr. Suresh Nair, Photonics Society Chair, for the constant guidance and mentoring. I express my sincere thanks to Dr. Kailas Nasser, he's the Vice Chair of Photonics Society Chapter, for the valuable coordination to organize this event. And I'm thankful to Mr. Hari, who has designed the IEEE Code of Ethics banner. Thank you, Hari. Finally, a big thank you to all faculty members, research scholars, students of ISP for the invaluable support towards this IEEE event. Thank you once again. Next.
Thank you, ma'am. I request all of you to join the unveiling of the IEEE Code of Ethics. The unveiling will be done by Dr. Pramod Gopinath sir at the C.V. Raman Square. After that, all are requested to join for the high tea. Thank you. After that, all are requested to join for the high tea. Thank you.